Allow me to introduce you to Rebecca and David. They've been a couple for many years, and they've been on a journey to start a new family. Unfortunately, despite their efforts, they have difficulties conceiving naturally, and they decided to seek an assistance from a fertility clinic. Now meet Dr. Tsarfati. She is a fertility specialist who runs her own clinic, and she wants to help Rebecca and David. She hears about their conceiving attempts, and she reviews their medical background, and together they decide that they want to start an IVF treatment. Okay, so Dr. Tsarfati looks at the medical records of Rebecca, and she wants to determine the best day for egg retrieval. Therefore, she needs to know what was the highest estradiol level for Rebecca. Estradiol is a hormone crucial for the ovulation process. Great. Dr. Tsarfati goes to her computer and starts to search. But she just can't find the answer for this simple question. Where are the hormonal tests stored of Rebecca? In which system should I look? Where is the medical background that she sent me? Where can I find it? Well, as you already understand, one of the biggest challenges of doctors is how they can query the medical information, the medical data of their patients. While this data exists in the databases, it is deeply buried and it's not easily accessible. And this is exactly the challenge that we wanted to solve for the doctors and medical care teams in the fertility clinics we collaborate with at MB. At MB, we're a startup and we develop a platform for fertility treatment monitoring designed specifically for doctors and medical care teams. My name is Shirli, Di-Castro, Shashua. I'm a senior data scientist at MB. In my professional background, I have a BSc in biomedical engineering and a PhD from the Technion in reinforcement learning. And today, I'm going to show you a little bit behind the scenes what happens when in our case, it was doctors came to us and say, hey, develop us this amazing AI tool that we can ask questions and receive answers immediately. I'll walk you through the development process that we have at MB for this tool. What were our concerns, which technologies we considered, what were the limitations we encountered. So let's begin. Okay, so this is Dana. Dana is the CTO of MB, and one day she comes to us and she tells us, she comes to the development team and she tells us, listen, the doctors in the fertility clinics that we collaborate with, they want us to develop them a tool where they can simply ask a question and just receive the answer. That's it. This is 2024. Why do they need to search for the information? Why don't they just can ask for it? Okay, we took the mission on ourselves. This is Yaron, this is the backend guy, and myself, Shirli, I'm the data scientist. At this point, I became the generative AI expert of the company. Sure, Dana, no problem, we'll do it in a few days. So if you want to develop a similar tool for your organization, where your customers can ask questions about data in their databases and receive answers, this is your time to pay attention. Okay, so we started with detailing the flow of our tool. On one hand, we have the question that we receive from the doctor. On the other hand, we have the answer that we would like to provide. Let's start with the question. What do we assume about the questions that the doctors are going to ask? First of all, we assume that the questions are going to be in free-form language, just like a doctor asks his colleague. Next, we assume that the questions might be complex. They might ask several questions in one query. They might ask questions that will require several data sources or several databases in order to answer the question. And one of the most important things is that we wanted our tool to be flexible enough to receive any kind of input. This is the problem. We do not know what they are going to ask. We do not know it in advance. They might ask about one patient, they might ask about several patients, they might ask about appointments, prescriptions, medications, we don't know. So we have to make sure that our tool is flexible enough to receive and to process any kind of input. What about the answers? First of all, we have to make sure that the answer that we provide to the doctor is authorized. It means that the answer includes data, only data that the doctor is authorized to see in the answer. Next, we have to make sure that our answer is relevant and accurate. Relevant, that the response directly answers the question, and accurate, that the data in the answer is based on real data from the database. We do not want any incorrect data to be included in the answer. Oh no, Shirli, how are we going to do it? How are we going to develop a tool that is secured, authorized, flexible, can deal with complex questions all at once? How are we going to do it? Relax, Yaron. LLMs, large language model. Didn't you hear about them? They've been developed tremendously in the past 2 years. Large language models can do, let's say, everything. They can generate text, they can summarize, they can translate, they can generate code, and they can answer questions. This is exactly what we need. So how do we combine large language models in our tools? Okay, so we have the question that we receive from the doctor. Naively, what we would like to do is to send the question to a large language model, to an LLM, and to tell the LLM, generate me a final answer based on the doctor's question and relevant data from the database. But here is the problem. How do we provide the LLM the relevant data from the database that it connected to the question? Remember, we don't know in advance what the question would be. We don't want to send to the LLM all of the data that we have in the database. This is a huge amount. We want to focus the LLM, to narrow it down, so it will have, in the context, only the relevant data that he can be based in order to answer the question. How are we going to do it? Well, we can simply add another LLM. So what are we going to ask from the first LLM? For the first LLM, we're not going to ask to generate the final answer. Instead, we're going to ask him to generate us a database query based on the doctor's question and based on the structure of the database. So the output of this LLM, it won't be the final answer, it will be a database query that is based on the doctor's question and the structure of the LLM. Then the LLM will generate us such a query. We will run it on the database. We will receive the database results. And now this is the relevant data, right? This is the relevant data that we wanted. Now, for the second LLM or for the same LLM at the second time, we can say, now you can generate me the final answer based on the doctor questions and the relevant data that I retrieved using the first LLM. So what are we going to focus now in the development process is this area of the flow. Which database query language should we use? Which works best with working with large language models? While we can connect our tool to also other data sources that are not relational databases, in this lecture we will focus on the connection we did to relational data bases. Yaron, listen to me. I am Shirli. I am the AI expert of the company. I read tutorials, I attend meetups, and I know that everyone in the industry, what they do, they ask the LLM to generate an SQL query based on the doctor question and the database structure that we will provide to the LLM. The combination of LLM and SQL, it gives us exactly the flexibility we wanted and the ability to answer complex questions. Because in SQL, you can do joins between tables. You can filter on any field that you want. You have the full flexibility to get any data that you want. Shirli, are you crazy? There is no way that I'm letting an LLM to generate an SQL query that is going to be run directly on my database. No chance. This is totally not secured. What if the LLM will generate a code that will delete my database? Or what if the LLM will generate a code that will fetch all the database and will crash the system? There is no way I'm letting you do it. Relax, Yaron, relax. Everyone is doing it. Also, LangChain wrote a tutorial about it. Shirli, I'm sorry, there is no way. I'm very scared that the PII, we'll have a problem with it. You know that we are Ambi, we are a company in the healthcare field. So we have to separate between the database of the medical information of the patients, and we have a separate database of the PII, of the personal information of the patients. So when you are saying that your LLM will generate an SQL query based on the doctor question, it will ask for the patient name, but we don't have a field of the patient name in our medical database, so we cannot even run this query. Okay, Yaron, no problem. So what's the problem? So we will write a function that will convert from the patient name to a patient UID, and we will insert it inside the LLM-generated SQL query. No, I'm sorry. This is not enough. I'm also very concerned about the authorization roles. Again, we're a healthcare company, and we make sure that if the doctor wants to see information in our system, I'm Yaron. I'm personally implemented roles, and these roles are making sure that only authorized people are seeing the relevant data. I don't want a doctor to ask a question. The LLM will retrieve information, and then I cannot control what he sees. I have to make sure that, that everything is authorized. Okay, so what's the problem? I say to him, what's the problem? So let's say, after the LLM generates the SQL query, let's validate it on runtime. And then we can add several fields to make sure that only the relevant doctor, only the relevant clinic fetches the authorized data. I'm really sorry, Shirli, forget about it. No way. I'm not letting you letting LLM generate an SQL query that will be run directly on my database. If you want, I may consider that we will use REST API. REST API is secured because REST API is just HTTP request, right? In REST API, you have an endpoint according to each data type. I've already developed these endpoints, and the LLM can generate a REST API endpoint request according to the data type of the question. We will run it. It's secured. It's authorized. I feel comfortable with it. Yaron, are you kidding me? Really? REST API? Didn't you forget that we have the problem of overfetching and underfetching with REST API? The problem of overfetching in REST API is because REST API, the response is predefined. It's predefined by you, Yaron. You wrote the response of each data type in a REST API endpoint. So you already predefined the fields that are going to be back to the client. So if, for example, Dr. Safati question, she will ask about estradiol tests. Which endpoint do we have? We have only the lab test results endpoint. This lab test results, you defined that all the lab test results are going to be returned. So the LLM will receive all the lab test results of the patient instead of just estradiol test. And also the problem of underfetching, it's the same but opposite. If Dr. Safati will also ask about a field like, let's say, the cycle number of the lab test result that you did not define in the response, so the LLM won't have the results when he asks for this endpoint. So it will start to ask for additional and more endpoints, and it will mess everything around. The combination of LLM and REST API, we wanted our tool to be flexible. We wanted it to be able to answer complex questions. REST API ruins us the flexibility. I want us to develop the tool with SQL. I'm sorry, Shirley, forget about it. We can develop it only with REST API. Oof. Well, actually, I understood him. He's got a point. The database, it's the holy database. And we have to make sure that a code that is run directly on the database, it has to be generated by someone who knows what he is requesting. And LLMs, with all due respect, can do stupid things. And even if we do a million of tests and million of validations, it's still, LLMs are uncertain. And we cannot let LLM to generate code that will be directly run on the database. It's very risky. So what I did what I do generally in these cases, and I consult with colleagues from the NLP community, from the developers community, and I just told them exactly what I told you now. And I asked them, what would you do? And one of them told me, did you consider GraphQL? I didn't know what's GraphQL at that point. Yaron, what do you say? What do you say that we'll try GraphQL? GraphQL, what is it? So let's understand what is GraphQL. So GraphQL is also a query, a language for querying databases. Just like RestAPI, it has an endpoint that the client sends to the server. But in RestAPI, we had different endpoints for different data types. Each data type had its own endpoint. In GraphQL, you have only single endpoint. And while in RestAPI, you had the problem of overfetching and underfetching, in GraphQL, you have exact fetching. The client can ask only the data that he needs, and he can receive only the data that he requested. And how can we achieve it? By three components that GraphQL has: schema, query, and resolver. So what is this schema? Schema is how you describe the data that you have to the client. You do it by writing types. That you define the types that you allow the client to ask. You can define as many types as you want and as many fields that you want, but the beauty of it is the client can ask only the fields that he wants from each type. He don't have to request all the fields in the type. Next, you have the resolver. The resolver is how you fetch the data. These are functions that you write, the developers, the data scientists, you write this function. You have a function that you can write a resolver function for each data type, and this is how you define how you retrieve the data from the database for this specific data type. This is the beauty of it. In GraphQL, the separation between schema and resolver, between how you describe the data and how you fetch it, this what gives you the flexibility. This what gives you the ability to only ask for the specific data that you want in each time. You can request only the data that you want and receive only the data that you need. Then the client will, how would we query the data? He will write a query that is based on the data types in the schema, and he will select only the fields that he needs for its specific request. So let's say Dr. Safati wants to know the estradiol level, the highest estradiol level of Rebecca. So a possible query would be something that asks for the patient data, for the name, and the lab test results and all the information we want to know about the lab test results. The resolver is all where the magic happens. Because the resolvers, again, these are functions that you, the developers, you write them, and you can put them, you can put inside these functions all the guidelines that you want. You can define how you give back the data that the client asks. So the resolver enables us a secured fetch, because the query of the GraphQL is not run directly on the database. Like in SQL, that this is what we scared in SQL. The GraphQL query meets the resolver function. And the worst case that can happen that we will have an error, but nothing is going to be run directly on the database. The resolver also enables us authorization, because we can implement the guidelines, we can implement the roles inside the resolver, and if someone ran this query and he doesn't have permission, so we give back an error or a message or something like that. And the resolver also is what makes the GraphQL concept to be very flexible and enable us to answer complex questions. Because inside the resolver, we can implement all the PII problems that we had. The client can ask for the patient name. Okay, this is what the client knows. We inside can implement the conversion between patient name and UUID, or we can combine different data sources inside the resolver. We can combine databases. We can combine also other data sources in order to give back the data that the client asked. So LLM, the combination of LLM and GraphQL, gives us exactly what we wanted. It is secured, so Yaron is happy. And it is flexible and enables us to answer complex questions, so I am happy. The only problem is that it requires time and money. And I'll explain you why. When LLM generates SQL query, you can simply run it on the database, right? It doesn't require any development time. When it generates a REST API endpoint, if it's an endpoint that you have, you already implemented it because you use REST API in your system. But if we want to use GraphQL, we at Ambi, we didn't have GraphQL. We need to develop it. We need to write the functions, the types, the resolvers, so it takes time and money. But we liked all these advantages, so we decided to go for it. So how is it looked? So this is an example of Ambi portal. The doctors see the patient data, and now he can ask a question. Again, let's go with our example. What was the highest estradiol level for Rebecca Smith? So let's see what is going on behind the scenes. So behind the scenes, this is this ugly prompt that we send to the LLM. But let's understand what's inside this prompt. So remember, we have a question, we send it to LLM with a prompt. What does it include? Okay, so it has 5 components. This task description, output structure, GraphQL schema, examples, and original question. So task description. First of all, we are flattering the LLM. We're telling him that he is a GraphQL expert, and we want him to give us a syntactically correct GraphQL query based on, and we will tell him what we would like him to based on. So first, we describe his task. Next, we define how we want the output of the LLM, the response, to be structured. So we define a specific structure. This is the structure we defined. You can define your own structure. We wanted the GraphQL query, but we also wanted an explanation in free-form language about what the GraphQL query is retrieving, because we wanted to be able to explain what the data that was fetched. Next, we attach the GraphQL schema. So here is an example. This is an example of a schema of patient data. You see there are many fields here. The LLM can know if the field is optional or required. And of course, in GraphQL, you don't have to request all the fields. You can choose which fields are relevant to the doctor's question. Okay, so this is an example of GraphQL schema types that we attach to our prompt. Next, we give examples, like many others do in a few shots. Example: a question from the doctor. This is how the GraphQL query should be if this was the question. Again, he knows the GraphQL schema, and we wanted him to give us also an explanation. Here is an example of an explanation. And finally, of course, we attach the doctor's question from that she asked. Okay, now the LLM generates a GraphQL query. So you can see he generated a GraphQL query only on the fields that he needs to answer the specific question of what was the highest estradiol level of Rebecca. He can filter on relevant fields, and we run this on our database. First of all, of course, this is time for validation, right? The LLM generated something. It's something that we're not certain. We need to validate it. How do we validate it? So first of all, we can check the syntax. Remember, you are the one who wrote the GraphQL schema. You are the one who wrote this GraphQL query resolver. You know how a GraphQL query should look. So you can do just check the syntax of the query. The second thing that you can do is just run the query. And this is the beauty of it. You're not afraid. In SQL, we were afraid. Yaron was really afraid that we will run what the LLM generated. It will be run directly on the database. It can do something that we don't want. But here, what is the worst thing that can happen if we run the query? The worst thing that can happen is that we receive an error. And with error, we can manage. So we are not afraid. Now we run the GraphQL query on the database, and we get the results of the database. So this is an example of the results. Again, just the fields that we requested are in the results. Here are a list of estradiol tests results. And then we send it to the LLM with another prompt. This prompt is much more simple. We give, again, test description, the original question, and this database results. Now the task is generate us a final answer based on the question and the database results. And we attach the question and the results. Okay, now we get the final answer. So let's see how we show it to the doctor and which validation we do. Also in this part of the tool. So first of all, we declare to the doctor, this is an AI tool. That we want to train the doctors to be able to deal with this kind of new tools that they're not certain in their answers. So we want to make sure that they know it's generated by AI and they know to compare the data that they see with other data points. And how do we do it? We always attach to the final answer. The final answer is free from language, but we attach the real data from the database that we fetch with the GraphQL query. So they compare and see if the answer is correct. Next, we can implement also an NLP tool to extract interesting entities and compare them to the database to see if they appear. So, what have we learned today? First of all, we learned that generative AI and LLMs are our friends. They've been developed tremendously in the past years, and now they can enable us to develop tools that up to a few years ago we couldn't. So even if they are uncertain, we need to embrace this uncertainty and to use them. Now, if you want to develop similar tools in your organization, what you need to do is to look at your input. Is it complex? Is it simple? Do you know in advance which questions are going to be asked? You need to look at the output. Do you want it to be authorized, security aspects, how relevant and accurate you want it to be? And it doesn't matter which technological stack you're going to choose. We chose the combination of LLM and GraphQL. You can choose other thing, it doesn't matter, as long as you keep Yaron, the backend guy, happy. Thank you.